So rather than having a buy me coffee button or a tip button on my website, I thought I'd make a poetry NFT contract and a marketplace. Let me just show you that. So I chose Harmony Network because it's fast and it's cheap. Being cheap for transaction fees is a weight off your shoulders as a programmer, because with smart contracts you need to get it 100% right, and on other chains that can be quite expensive. So we've got traditional NFTs where there's an image URL in the metadata returned from the smart contract. It's just some symbolism. And then I have poetry NFTs. This is an SVG image with text elements, and it is 100% on the blockchain. As we see, this is the metadata returned from the contract. So if we take this base 65 encoded image, bosh that. So this is the text elements in the SVG. So for as long as the Harmony blockchain exists, this poetry will be on that chain. Life-giving, all-powerful one, light bringer to herald sweet dawn, the Father, the Son of heaven, the name of God in countless tongues. And then we have a marketplace where people can buy the NFTs. So there's that. To get started on Harmony, you first of all want to set up your environment. Now, I personally use Truffle. Truffle's nice. And to get started on the Harmony network, you are going to want this project, Harmony Box. And the reason for that is this file here, private provider. So if we look at this file here, truffle config, this is the configuration for the project. So Truffle lets you deploy, run tests, and run scripts for a smart contract. So here we have the networks. You've got local network, which runs on your computer. You've got a test net, and you've got mainnet, and they all use this private provider. Now, I need to mention something about the test net. We'll come back to that. So the Truffle config, in order to work, takes some variables. So your private key, network ID, and the RPC URL. Let's have a look at the environment file. So the first thing you do after you git clone, you do your traditional git clone, is you need to populate your environment file. Now here's an example, and you basically take your private key without the 0x prefix, and you paste it here. So if you're going to use a local net, paste it there. If you're going to use test net, paste the private key there, and mainnet again. And then you're going to want to have a wallet. So if you look at the documents for Harmony, you're going to look up networks and faucets. So do not use testnet. It's so this is your chain ID, and this is your explorer, and this is your faucet. So you need the faucet to get some harmony that you can spend on your contract when deployed on DevNet. Okay, so next you're going to want your contract. Now, smart contracts are easy, and especially with OpenZeppelin, they've got some very well thought out routines that you can use in your project. Now, the code is easy, but that's not to say writing a contract is easy, because you need the contract to be 100%. So even simple operations, you need to be 100% sure that there's no mistakes. So that's what makes it complicated. So this is my poetry NFT contract. Let me just log back in. There we go. So let's understand what's happening here. So we've got the NFT is a ECR 721. We've got a base URI, so you can deploy them on a distributed system like the interplanetary file system. I chose to just put it on this website, and maybe at a future date I'll run a interplanetary file system node, and then I could put them there. Then you've got your constructor where you want to put your ticker and your name of the contract. And then I like to use this function now, wallet of owner. Now this relies on token of owner by index, which comes from this contract, which is an extension to the ERC 721. Now, something I didn't realise about Truffle is that Truffle, or maybe it's in newer versions of OpenZeppelin, but this is automatically imported in this contract, in this Truffle setup. That's why I've got this commented out. So if I use this contract in a web IDE like Remix, I'm going to need to import this, and I'm going to need to put this contract is ERC 721 enumerable. So this function returns what is owned by the wallet, and without this you would have to use a third-party solution like the graph, for example. Whereas if you have this in your contract, you don't need to rely on third parties. You can just call this and boom, you get a list of all your NFTs. So what we do here, we get the balance of owner, so we get the token count, we create a array, we cycle through the tokens by the index and pop that into the array, and then we return the array, and then in the UI we can nicely display all of the tokens. Now, function text body, this is to generate the text in the poetry. So it's going through the characters in a text string, splitting at new line characters, which is hex A, and then putting that into an SVG element, and then packing that into a string, and then returning that string. Then we've got token URI. This is part of the ERC 721 standard. So this lets the user interface call to the RPC I want token URI, what's this one, number 4. So to get this NFT image here, we call this function, get token URI with number 4. And then here I'm just working out if the token is an image. I've come up with the convention that if this string, which I'm getting from this memory hash table, memory map, token data. So it's just mapping a number to a string. So we're getting the first character, and if it's a hyphen, then it's going to be an image, and I just pack the string with the base URI. Otherwise, it's going to be a poetry SVG, getting rid of special characters here. And then a nice little thing about this contract is I changed the color just because I thought, why not? Okay, so the NFTs change color based on the block number. And then here we are just packing the SVG together. And then we are returning the metadata encoded as base 64. And then here's my set base URL function and my mint function. Now this encode base 64 encoding function, I borrowed this from Anonymice, which is another contract, which is a pixelated art contract. So this is the function. And then for the marketplace was just forked from OpenSea, and we've got, it's fairly simple, we've got a struct for a market item, ID, NFT contract, token ID, seller, owner, price sold. Then we've got an event which is emitted when you sell an item. We've got a tax which goes to the developer. We've got, I decided to only allow approved contracts, so I keep an array of NFT contracts. So that means only approved NFTs can get put on this marketplace. So that's what this function is. It cycles through that array of contracts and checks to see if the argument is in that array, and then the owner of the contract can add new approved contracts, and the owner of the contract can remove approved contracts. And then we've got this function, which is part of the the standard. So if you want to use this function, save transfer from, this function is considered safe because it looks for this data being returned. So if you're going to use this function, and here we are getting the NFT that is getting sent by the owner. So for example, I go here, and I want to sell this item. I'm going to send data to this contract. This contract's going to create a strut item and store that, and then it's going to transfer ownership of this NFT to this contract, and that uses this function, save transfer from. So if this function does not get this reply, it will revert, which means that the NFT will go back to the owner. I keep track of the highest price which are sold in order to put a cap on inflation. So get max sale price. So the max sale price will be the highest sell price times the inflation cap. While the functions, we've got remove market item. So that's just so that the owner can remove it. Then we've got buying a market item. Some goes to the dev. The tax goes to the dev. The rest goes to the seller. And the NFT gets sent to the buyer. And it gets marked as sold. And then a function to fetch all the items on sale. And then a function to get the buy history of the wallet owner. Next, let's come to tests. So, to be 100% sure you're ready to put the contract on the mainnet, you're going to want to write tests for everything. And that means everything. So Truffle makes it quite easy to do tests. So here we've got our files, and literally every single function, even if you think it's silly to write a test for it, and think of if and when it should fail. So get name and symbol. Even if you think it's silly to write the test, just write the test, because anyone can make silly mistakes, and it just saves a lot of time to get rid of those silly mistakes. And if, for example, you're on Ethereum, silly mistakes can be very expensive. Yeah, so here's the result from the function call, which is truffle test. Truffle test will just run these files. So here are the responses from my failed tests. Contract, NFT, failed to remove someone else's market item. So obviously that's meant to fail, so that's a good thing. Failed to sell due to above inflation cap. Again, it's expected to fail. So you need to make your use cases and just methodically test everything. Once that's done, you can put on the mainnet, truffle migrate, skip dry run, network mainnet. And it on Harmony, it will cost like 10p or something, which is great. So that's my Poetry NFT contract.